on recording. Okay, so we left our lecture on this sensory systems, okay, and I teach you all the types of sensory transducers, okay, the mechanoreceptors, photoreceptors, chemo. So I have taught you till here, okay, I have taught you till here. So we left our lecture here. So now the next topic, so today's topic is so first of all we will cover like 3 topics today. One topic will be on the characteristics of nerve fibers, okay, so basically they are the types of nerve fibers, okay, and then another main topic of today will be action potential, because all of this next you see the receptive field and all these steps in the sensory transduction, all of these steps in the sensory transduction, okay, along with the adaptation, okay, are all of these things are the part of action potential. So you need to understand how an action potential in a nerve is generated, okay, and then there is a few terminologies that's being used in case of nerve fibers. One is adaptation, and there are 2 more which are not given in your book, but I will tell you that they are very important to know, okay. And then we have this sensory pathways from the sensory receptor to the cerebral cortex. So basically it looks like this topic is very small. This topic looks like very small, but this is not that small, okay. It is very complex. So it will take our today's lecture completely. So once you will be like done with understanding the sensory pathways of how the stimulus reaches the cerebral cortex, it will be easier for you to study uh, the the main somatosensory system, in which you will study everything differently. Like you will study all the pathways and tracts of the dorsal spinal column, and the dorsal thalamic tract and the ventrothalamic tract, okay, and all those tracts, how they're working, and then also the vision, the hearing, all of those mechanisms you will be studying in the somatosensory system. So today's lecture is basically the base of the somatosensory system. So that is why I focused on today's lecture, that it is very important. So let's begin it. Okay. So this is a chart, okay, of in your BRS book. This is a chart that shows the characteristics of nerve fibers, okay, and these are the types of nerve fibers. Now let me tell you, when we classify these nerve fibers, we classify them on the basis of so many things, okay. So one of the classification that has been done on the basis of diameter and on the basis of the conduction velocity is this classification. This classification is very important classification of nerve fibers, okay. This is done on the basis of diameter and on the basis of conduction velocity. So there is a scientist whose name was Erlanger Geyser, okay, whose name was Erlanger Geyser. And let me write it, if you like kind of want to write. Neuro is my favorite portion in physiology, okay. So like I kind of give lots of interest and respect to this chapter. This is my favorite one. So you know, there is this scientist Erlanger Geyser, okay. He characterizes these nerve fibers on the basis of 2 things. The first is the diameter, that is the thickness of the nerve fiber, okay, and the second is the conduction velocity, okay. The second is the conduction velocity. So there is a chart also diameter and conduction velocity as in numbers, I will tell you, I will write it here, okay, to tell you. Let's make another small column over here, so that I may tell you the diameter of these fibers, okay, and I will write their conduction velocity in numbers over here, okay, in this column, so that it will be easier for you to understand, because this chart is very important, and they do ask MCQs on this chart, okay. So pay your focus on it. So this classification is called Erlanger-Geyser classification, okay, and is done on the diameter and conduction velocity. So we have these fibers, okay, alpha, beta. We have, first of all, we have these fibers A, B, and C. Okay, we have these A, B, and C nerve fibers, and then he divided the A fibers into four categories: A alpha, A beta, A gamma, and A delta. So you will be like, this is the symbol of alpha, okay, and then we have this symbol of beta. So you should know the symbols as well. This is the symbol of gamma, okay, and then this is the symbol of delta, okay. So because in your first state they have written symbols, so you should know the symbols as well, okay. So this is alpha, this is beta, this is gamma, and this is delta, okay. So they have divided A fibers into further more classifications, but then we have this A alpha into two more, 1A and 1B, okay. Alpha is further divided into 1A and 1B. So how are we classifying? We are mainly classifying our nerve fibers into A, B, and C, okay, and then A is being classified further into four: alpha, beta, gamma, and delta. And then alpha is classified into two, that is 1A and 1B. So this is like a flow chart of the classification. Now let's get into its detail. So when we talk about the diameter, it's just written in your BRS that the A alpha fibers have this largest diameter, okay. So if you like want to get into a little bit more detail on what is the size of this diameter, you can write it in your book. It is 12 to 24, okay. 12 to 24 is the size of this alpha, and this value is in microns, okay. So this is micron. This is a symbol of micron, so it is in microns, okay. So 12 to 24 microns. And the beta ones, which are medium, how alpha A further divided into four. Alpha A is further divided into four. Alpha A is further divided into two, 1A and 1B, okay. A is further divided into four. You see this A alpha, A beta, A gamma, and A delta. This A is further divided into four, okay. And they are further divided into four on the basis of their diameters and conduction velocities, and also definitely their locations to which they are giving their fibers to, okay. So do not confuse at this level, okay. A alpha is further divided into two. How and why? I'm telling you how and why, okay. Why they are divided? Because there is a major difference in their diameters. If I okay let's say, for example, you have this A, okay. If I talk about only A, the range of diameter is I'm writing it over here, I don't have space, okay. It is from 12, okay. Not from 12, it is from 24 to from 24, okay, to 2. 24 to 2, only an A, okay. And when we comes to B, okay, it is 1 to 2. This is the diameter. If we come to see, it is even less than 1.5 microns. So now you see this is a huge number from 2 to 24. They need to divide it further, because when they were studying, you know, all these nerve fibers have been studied in on a giant squid uh, previously. Now they are studying it on human nerves. Okay, earlier they studied it on a giant squid. Okay, that was called linogo. So that's your general knowledge. Okay, so when they studied it on that squid, they divided into A into this 4. But when they further studied it on human and other mammals, okay, and then humans, they have to divide it further into 2, because of their impulse, the conduction going to the location where it is. Okay, that is why this is how they classify. That's the answer to your why and how. Are you okay with that now? So let me clear this all up mess. Okay, so you have to you can, if you have the book in hard copy, you should write it, or you can make your own chart. Okay, so now let me take you with one with A alpha only. Okay, so you should know the diameter is from, why I'm writing 12 first. It's from 24 to 12. Okay, like from higher to the lower one. Okay, and then the beta one will go from 12 to 6. Okay, and then the gamma one will be like 6 and 5. Okay, I'm going in a descending order. Okay, and if I'll talk about delta, you will see delta from 5 to 2, because the b one was like 2 to 1 or 1 to 2, and then this is less than 1.5. So or you can take it as like 1.5 in order to remember. So these are the diameters in microns. Okay, so this was the one way to classify them, and like one basis. The other basis was conduction velocity. That, you know, on what on what things the conduction velocity depends on the myelination. The myelin sheath determines the velocity will be fast or the velocity will be slow. Okay, so and also the gap junctions present in between them. So not every nerve fiber has the same number of myelin sheaths. As I told you in my previous lectures, the peripheral nervous system is has this myelin made up of Schwann cells. Okay, and your central nervous system myelin is made up of oligodendrocytes. So one oligodendrocyte was enough to myelinate one neuron, but 9 Schwann cells were myelinating one neuron. So that was, you know, difference in the myelination also. And then the number of, of sodium sodium channels present, because you have heard that I have also told you the structure of neuron in my previous lecture. So if anyone has not listened, please go and listen it. I told you regarding the node of Ranvier and the saltatory conduction, how it occurs. From the conduction jumps from one node of Ranvier to the other node of Ranvier. Okay, so that we call it a saltatory conduction. So I'll not go back to that previous lecture, but we will focus it on today's lecture. So these are the two parameters, first of all. Now let's talk about the what is the function of these. Okay, so the important things comes now, which are asked now. These diameters and the conduction velocity are not asked in your exams, but I am kind of telling you because to make you understand what this chart is about, because most of the students find this chart really difficult. Okay, so now the MCQs are starting. That A alpha fibers are the are of the motor neurons. Like what are the motor neurons and what are the sensory? The motor neurons are the one that take the impulse that have been generated and that has been reached to the central nervous system. So from the central nervous system, they are taking it to the effector organs. Okay, they are taking it to the effector organs. So those are the motor neurons. So there are some motor neurons that have this huge diameter, that has a fastest conduction velocity. Okay, and if you want me to tell you the numbers of conduction velocity, like I can tell you, but that's of no use to remember. Okay, so for the fastest, just remember it the range is from 70 to 120 millivolt. Okay, like not millivolt, it is meter per second. That's the voltage. Okay, it's meter per second. Okay, so this is like 70 to 120, the fastest one, and the slowest one, just remember, just I'm telling you for making your concepts more good, 0.5 to 2 meter per second. Okay, so this is how this velocity, this current flows from a neuron. Okay, and they are motor ones. So where they're reaching, what are their effector organs? They're like muscle spindle afferents. So I told you in my first lecture of neurophysiology the concept of an afferent fiber and an efferent fiber, an afferent from A and efferent from E. So if you're new, I'm repeating it again. The afferent fibers are the one that take your stimuluses to the central nervous system, and the efferent ones that bring back. Okay, so this is an example of this muscle spindle afferents. Okay, then we have this, we will see this chart in the first aid, but first I want to cover this one. Okay, then we'll move to another chart which is from your first aid book, very important, and connects this chart too. Okay, then we have this A beta, and it is responsible for touch and pressure. Very important point. Touch and pressure, you have to remember this, because A delta is also responsible for touch and pressure, but there is a difference between these two. One is for fine touch and one is for crude touch. You know, there is a fine touch and there is a crude touch. So here is where the difference lies. So for if you remember the previous lecture of the receptors, I told you regarding the Meesner and the Pacinian corpuscles. Okay, and the Merkel Disc or the Roofinis, etc. So you should know that for when we talk about the fine touch, okay, we are talking about this Ruffini. Okay, so now here when I talk about the touch and pressure, okay, they, because their diameter is more, okay, because their diameter is more, they can take in even the crude one. But because their diameter is small and their conduction velocity, that's how we can distinguish. Now you can also apply this onto your skin. Okay, just give your from one hand, give your another hand a very slight fine touch. Okay, and that stimulus will reach to your brain really fast. Okay, so the more the diameter, the more the velocity. The smaller the diameter, the smaller the velocity. But in case of crude, it's not like you're sitting and one of your friend comes to you and he just put your finger on your hand very finely, and you will eventually draw back that part of your body. Okay, but if he will do like really hard, or like in a dragging or in a slippage position, so that you will be like fine, you will not draw back it so quick. So that reflects that you're performing also determines that how fast or how slow the conduction went. So remember A beta for the touch and pressure, but then A delta has temperature and pain too. Okay, important things. Okay, this 1A 1B 2A 2B is not that important, but these things are important. Okay, Then we come to A gamma. Let me clear this mess. When I come to A gamma, we have this motor neurons to muscle spindles. Okay, then again I'm talking about these muscle spindles, but they are different from these ones. Okay, they are, these ones are just taking the impulses to the CNS directly, and also, and not interconnecting the interneurons. If you the spinal cord segment, I told you this is the dorsal, this is the lateral, this is the ventral, and then ventral again, and then lateral, and then dorsal part, the spinal cord. If this is your spinal segment, this dorsal one is the sensory, and this ventral one is the motor. Okay, so we are talking about the motor one. Okay, so in the somatic system, not in the autonomic. Remember, when we are talking about skeletal muscles, we are only talking about the somatic nervous system. In the somatic nervous system, we have a sensory, we have a motor, and we have an interneuron. So that interneuron that is present at this particular level, okay, has this gamma fibers. That is the difference between alpha and gamma. So remember, okay, both of our muscle spindles, both of their actions will go to your skeletal muscles. Okay, okay, will not go to your skeletal muscles. From your skeletal muscles will come to your central nervous system. Okay, so you should be clear in that point. Then I have told you about this delta. Okay, and then come to this B. We have this preganglionic autonomic fibers. Now, very familiar terminology, preganglionic. I have repeated multiple and multiple times. What is a preganglion? This is a neuron, preganglionic neuron, and then this is a postganglionic neuron. So this area is your synapse. Okay, so this fiber is the preganglionic fiber, that is taking the impulse from your central nervous system to the ganglion, not reach to the effector organ level, only up till here, halfway. Okay, so these are the fibers of the preganglionic autonomic nerve system. Okay, but now when it comes to C, they have the smallest diameter, less than 1.5, and thus the conduction is the slowest. I told you the conduction. Okay, so the slow pain and postganglionic autonomic fibers, now they are responsible for slow pain, and postganglionic means there we are talking about this fiber. Okay, so now we are going to the effector level. So it is essential to understand this picture. Okay, and now I'll take you to this picture from your first aid book. Very important, like if you're giving your NEB exam, if I have students of NEB right now who are online, learn this chart. You will get in the previous exam. In the previous exam, we got 3 MCQs straight from this chart. So very important. Okay, now they ask MCQs on Meesner, Passinian, Merkel Disc, and Roofini more than free nerve endings, because that's easy. Okay, so what they ask is that Meesner Corpuscles. Now if you're like kind of what are these? So when I taught you this portion in the previous lecture, if someone has missed, please go and check the previous lecture of neurophysiology. The touch one, okay, इन्होंने यहाँ पर सिर्फ Passinian का जिक्र किया, okay, only Passinian has been discussed here. So when we talk about Meesner corpuscles, we are talking about the touch ones. Okay, so I have like told all that thing in too detail, and I also showed a picture from your neuroanatomy snell for this chart. So please go and check that. Okay, and then I told you about the Roofini as well, that they were for the warmth. Okay, so you kind of they are like for the temperature. Okay, So if you, but this is not given so good in this book, so that is why I am touching your first aid here. So it's like direct. So you see Meesner corpuscles, they're for your fine and light touch. So that means we are talking about these fibers. We are talking about the beta ones, okay? We are talking about the beta ones because their conduction is medium, that is faster than delta, so they will reach more quickly. So fine always reach more quickly, so their sensory neuron fibers are large, or in BRS it's written medium. So remember, like this is what we are talking about here, okay? The beta ones, Meesner corpuscles, the fibers are beta, okay? The myelinated fibers, definitely they all should be myelinated, because they are the myelination, the more the myelination, the fastest the conduction. This is the simplest rule, okay? If the conduction is slow, myelination is less. If the conduction is slowest, there is no myelination, okay? So remember this rule. So all the conductions that are faster, they are fully myelinated, so myelinated fibers, okay, and adapt quickly. So we will talk about the adaptation, just skip the adaptation mechanism here. I will tell you what adaptation means. And when we come to the location, they are present. Now the location is important for your MCQs, okay? Glabrous hairless skin means the skin of your palm. So now they will not ask you an MCQ of hairless skin. They will say the what are the fibers that are responsible to take your stimulus to the central nervous system uh, from your palm of hand or from your sole of foot. So now your concepts should apply that they are talking about palms and soles, that is glabrous skin, and the fibers are A beta. The fibers are A beta, okay, and the receptors for them are Meesner corpuscles. So this is important to remember. You can write it in your book, okay? So we have this dynamic, means very fast, okay, and dynamic, fine light touch, and position sense also, and low frequency vibration. But this fine light touch is your main MCQ point that is asked, because we have another touch also now. That is why. So let's come to the Pacinian corpuscles. Are you people understanding what? Please respond. Are you people understanding? Because this lecture is very important. Okay. Now, when we come to the Pacinian corpuscles, you see again the sensory neuron fiber type is the same. Okay, but the location is different. Okay, very good. The location is different. It is deep skin layers. Okay, and you know the skin has 5 layers. So we are not talking about epidermis now. Okay, deep skin layers. So when you apply a deep pressure, so you see pressure senses, but this pressure is deep. So the fine pressure is like just of a pin. Someone comes and pinch a pin in your skin, okay, very lightly. That is superficial. Like epidermis is involved and the nerves below the epidermis is involved. But when we talk about all the deep skin layers, we are talking about a deeper pressure. Okay, so deep skin layers, ligaments and joints. The location of Pacinian corpuscle is important, okay? And then the senses, high frequency vibration and pressure. So if you, if any one of you have ever gone through a a massage therapist, there are some chiropractors, okay, and there are some massage therapists that do massages of the ligaments and joints. For example, a very common problem is frozen shoulder, and there are some chiropractors that work on them. They give this high frequency vibration to check their nerve impulses, okay? So they are basically activating these Pacinian corpuscles. So this is how like you can also remember, as in I'm giving you an example of it. Okay, and then you have this Merkel disc. So in case of Merkel disc, we have the same, the neuron fiber type is again the same. So Meesner, Passinian and Merkel's are the same, okay, exactly the same. But then you see fingertips and superficial skin. So your fingertips, you can like pinch the nail of your thumb to your index finger. So you feel a pain, a slight pain, a pressure. But are you withdrawing? You can like give more pain and pressure over here. They're like hard, okay. But when you you're constantly giving pressure and pain to your finger, then you will withdraw. So the receptors responsible are Merkel discs, okay. So they are also for the deep pressure and the deep static touch. Example, shapes and edges or position sense, etc. So let me tell you the important MCQs. Meesner Corpuscles, you have to remember the location and fine and light touch, okay, and low frequency vibration. But in Passinian, you have to remember all of them and this completely deep pressure, okay. In Merkel discs, you have to remember fingertips, okay. Remember fingertips. In like these are your MCQs, straightforward MCQs, okay. Roofini corpuscles now. In Roofini, I told you Roofini are like they are also for temperature, but if like it's not written over here, but they are for warmth, okay. Warmth. So now the type is dendritic endings with a capsule. You see, whenever there is a capsule, whenever we are talking about capsule, they are responsible for temperature because they prevent those endings to damage. Okay, heat can damage the dendritic endings. So capsule is a cover to them. So our nature have protected our nerve fibers too, okay, and they adapt slowly. So now when I'm talking they're adapting slowly, will they be A fibers? No, they are not A fibers. Okay, now we are talking about the B and C one, okay. And if we talk about the mostly C, but when if we are talking about in A category, they can be delta, but not all of them, okay. Mostly they are C. So this is the location you need to remember for both of them. So if you're talking about fingertips and a faster conduction, we're talking about Merkel disc. But we're talking about fingertips and a slower conduction, we're talking about Ruffini. So now you see slippage of objects along the surface of skin, like the dragging sensation. The dragging sensation. When you have a fine touch, you will withdraw your hand quickly. But when something is being dragged on your skin, okay, even your own finger, you will not like uh, pull your hand back quickly. So this is asked in MCQs, okay. Joint angle strength, they don't ask these things, but they do. Their favorite MCQs are of pressure and touch, okay, with these receptors. So you have to understand this all. Then let's see this also. Free nerve endings, okay. Free nerve endings with temperature are the more common, okay, present in all skins, epidermis, and some viscera. Okay, let me tell you one more thing about viscera. The viscera, not all, like most of the viscera do not have pain receptors. You can't feel pain. Your liver is cut. You can feel pain if, just say for example, a little, this is not possible. I'm just trying to make you understand. A little person gets into your abdomen, okay, with a knife, and that little person is cutting your liver or cutting your stomach. You will not feel pain because there are no pain receptors on your viscera. Only some viscera have pain receptors, and that includes your auditory ones. Your gut viscera do not have pain receptor. Your pancreas, liver, gallbladder, stomach, small intestine, large intestine, okay, and your heart, your lungs, they do not have these pain receptors. When you now you will say that we do feel heart pain. Why you feel heart pain? Because when your myocardium, when your myocardium has another layer on it, okay, which we call epicardium, okay, and then you have this layer of muscles, okay, above it. So when your pain from this myocardium reaches to this epicardium, and then you have this cavity, okay, this pericardial cavity. So when you reach at that particular level, okay, then you feel pain. Similarly, when we talk about lungs, okay, you have this two layers on your lungs, okay, the visceral and the parietal, which you call pleura, okay, the visceral pleura and the parietal pleura. So when your lung is inflamed, or you have a parenchymal lung disease, when your lung is being touched to this parietal pleura, then you feel pain. You do not feel pain at the level of viscera. Always remember this. How you feel pain in your stomach? That is, your stomach and your small intestine are not generating pain signals. They are being touched. When you have bloating, your intestine is touched to your peritoneum. Your peritoneum has pain receptors. Your intestine or your stomach do not have pain receptors, okay? Just keep this concept very straight. This is an important concept to understand, because if you will have this concept, you will not do your MCQs wrong, okay? Then alpha delta is fast. Myelinated fibers, I told you, more the conduction, more the myelination. C is the slowest one. Unmyelinated fibers, so they have made a mnemonic also for you to remember. So now we have less than 1 minute. Please join again for the next topic, that is action potential. We are done with the fibers and the receptors, okay, sensory receptors and the types. So I may end this recording here, and just now I'm ending it. And please join again from the link that is given in your WhatsApp group, okay? Please join again so we can study